I hope I can hear me. Okay, great. Hello, everyone. Before we begin, I'd like to thank you all for being here, and thank to CND organizers for making this wonderful event happen and for giving us the opportunity to present today. So please, a warm round of applause for them. A quick introduction about us. My name is Maria Oprea. I'm an account cloud engineer at Oracle. And together with my colleague Adrian Birzu, who leads with expertise in observability and security, we are going to present how Open Telemetry fits in an AI-driven landscape and actually how you can start applying it programmatically across distributed AI systems. In today's agenda, we will start talking about one of the use cases, multi-cloud AI use cases that we've worked on, where actually multiple agents operates in different environments. Building on that, you will see how Open Telemetry fits in the scenario and the role it plays. Then we will continue to understand what is missing when AI and LLM components enter in the architecture and why traditional observability is not enough. Then we'll have some practical examples of how Open Telemetry works, actually how Open Telemetry integrates with other open source observability frameworks. And at the end of the session, we'll draw some conclusions. We will have some key takeaways and obvious Q&A session where you can address all of your questions. As I said, we had a customer, a multi-cloud AI customer. They decided to have this strategy. They wanted to be flexible to avoid being vendor lock-in. And also, they wanted to take the advantages of every cloud provider, every AI services provider. So their ecosystem was split like this, customer-facing workloads. They were running chatbots powered by Azure OpenAI to handle support requests. And on the other side, they were using for more critical workloads for internal operations, they were using Oracle Cloud Infrastructure or OCI. From OCI, they were using OCI dedicated cluster for model training. Also, they were using OCI GenAI services to implement financial analysis agents. Oracle Database 26AI plus vector search for securely storing sensitive data, for semantic search, and to meet strict compliance regulations. They were using application performance monitoring and were running on OKI, Oracle Kubernetes Engine. And on top of that, LangGraph to coordinate the agents and to orchestrate workflows involving LLMs. The idea is that their business ended up with distributed AI systems. So the question here is how do they get an end-to-end visibility and monitoring, troubleshooting of these systems? Because there were different tools, different dependencies. So our approach was to introduce Open Telemetry in order to collect the traces. Through traces, I mean logs, metrics, I don't know, we introduced also Prometheus for backend in order to store metrics about CPU, memory, and latency, also Tempo for traces. We integrated also LangFuse in order to understand the LLM behavior, to say so, actually what prompt was sent, what model replied, how many tokens were used, why the AI model hallucinated, things like cost analysis, yeah. For the visualization layer, we introduced Grafana for dashboards, for alerting systems. So in practice, the flow was this. We installed in LangGraph, in the workflows of LangGraph, we installed OTel SDK. And by doing this, we were able to trace the most important steps of the AI workflow. Then Open Telemetry Collector was like a central pipeline for those telemetry data. Open Telemetry Collector was running in OKI, Oracle Kubernetes Engine, and this took data from the SDK and then forwarded to the backend to Langfuse or, I don't know, Grafana and so on. Before going further, I'm really curious how many of you have actually used Open Telemetry in the AI use cases. Raise your hands. Oh, I didn't expect that answer. Basically, Open Telemetry was built initially to monitor infrastructure, to monitor APIs, microservices, and the next layer for this was, okay, I really need to understand what is happening behind an AI request. Yeah, because we are talking about distributed AI systems. So they have now an extension called GenAI Semantic Conventions, which actually creates a common language for all the AI to understand. Actually, they standardized a way of naming and collecting the data, and it's now marked as in development, but you can use it but yeah, you can expect some changes for the next versions. Yeah, now in the next part of the presentation, Adrian will show you how actually Open Telemetry evolved from understanding infrastructure, traditional monitoring to become more AI workload stuff. And also you will see how Open Telemetry integrates with other open source observability services, and also a live demo with a comparison between observability services that we want to show you in this use case. So Adrian, over to you. Thank you.
Okay. Hi, everyone. I'm happy to be here. Thanks, everyone, also being here with us. So what we need to understand a little bit, yeah, when we started this journey into monitoring the AI world, it was last year. So from this initial, let's say, deployment, this initial monitoring and observability service, we added a lot of additional new features, because as Maria said, this is in continuous evolving. So if you're gonna go on the Open Telemetry projects for the AI, you're gonna see a lot of new things every week, let's say. So we started basically with this part. And from here, we wanted to go and get a little bit more insights on what is happening into, let's say, a cluster or into an AI agent and things like that. So the initial tools, yeah, as Maria said in there, yeah, the customer was already an APM customer. He knows about it. He knows how, let's say, they were looking into their application traces. They know how they can do drill downs into the data. They know how they can go and, let's say, search for additional, let's say, insights. They know where to find an error into the logs and so on. But when it came, yeah, to the option, yeah, to see what's happening into the AI, this type of data was not collected yet. Okay. At this point, yeah, some of the data that you're seeing in here, it's collected using agents, and some of the data using Open Telemetry SDK. So I give you an example. Yeah. So this is, let's say, a chat. Yeah. So it is a more advanced chat agent. It is used for multiple different locations. It's not a customer one. Yeah. So this is something that you're using right now for demoing different things. But we start, let's say, with the agent capabilities. So an agent, yeah, can run, yeah, against multiple tools in the backend. It can run against multiple cloud providers. It can run against different pipelines, yeah, that you have in there. It can run and query directly the logs into the log analytics solution. It can also start doing running SQL queries and so on. So this agent here has, let's say, this in mind when it was created, so I can go and ask him certain things like he can see if we have some running SQLs in the backend. Yeah, so I'm gonna go, I'm gonna ask him to run this. Hopefully it's gonna work. Okay, I'm not able to see. So I have no actively monitor SQL on the cluster, but let me go and run maybe on a database side. Let's see what tables we have. So when you're running all of this, you're not able to see what's happening in the backend. Yeah. So if you're not starting implementing a solution for observability, it is going to be something that will not provide you the advanced visibility that you want to see it in there. So when I run something like that, something happens. Yeah, all of this, all the commands, everything that is happening in there, it's generating a workflow, and that workflow, yeah, is looking at different things. Yeah, so I can see I receive a certain query. Yeah, okay. So what are the running SQLs on that database? I also want to see what is the intent. Okay, the AI identified what is the intent on what to do. He has a confidence that he knows where to send my data. After that, yeah, he wants to do a classification, and at the end, it gives me the response. So this is basically, let's say, the short way on how an agent is working. Now, we needed more to see than, let's say, something like this development. So at that point, we started using different tools to understand it. Yeah, we also used the APM, but it was not at the level that we wanted to have it. So what we we add an additional layer, yeah, and that layer at the end will be LangFuse. But until then, let's say we also started with OpenLead. Okay, so in OpenLead, as you can see in here, yeah, we have the request, we have the trace IDs, we can click on it, we can drill down, we can see the span attributes and so on. So this was pretty interesting at the beginning. Yeah, we thought, okay, we found a solution that goes a little bit more than we needed. So yeah, might be the good solution. But we start continuing with the implementation and the research. So the next tool that we went over it, and we want to go a little bit more, was Phoenix. Yeah, so initially, yeah, Phoenix project, another open source project that is very cool. Yeah, they have a lot of things. But as you can see here, missing things. Yeah, I'm not seeing not even what I was seeing initially and the other tools. So yeah, also this was one of the projects that we ditched at that point. Hopefully, yeah, they will advance more in the future. And at the end, we moved to the LangFuse. Okay, so when you go into the LangFuse, you're gonna see that you have additional views. Yeah, so that's why we like also like LangFuse at that point. So this is, let's say, a question that we put it. You can see the full path of the question that we have it in there. If I go back in here and let's say, let me look for something earlier. You can see here that you can also see directly everything pre-calculated. Everything that you see in here didn't need additional changes done in the backend. Yeah, we created the project. We specify what is the API key that the SDK needs to connect to it. We specify what was our, let's say, destination in the application, and the agent started to sending the data directly in there. So at that point, yeah, that was the solution that we decided to go forward, and right now we have hundreds of customers that are using the same approach when we talk about yeah, the AI monitoring workload. Now, yeah, if you go a little bit more into this is just the beginning, okay? Initially, if we want to go into certain data, we can identify things that are happening in there, but still is not enough, yeah? The AI, it is, let's say, a complete new world, yeah? We think we know things about it, but we don't. So at that point, we have something that are called, we need to go and use LLM also as a judge. Yeah, we use an LLM to understand more about what we're doing. Okay, so we collect the traces, we have the spans, we have all the details that we need in there, but let's go further. So at that point, what we can do, we can go and we can add additional observation, yeah? So at that point, we have different queries that are done in the backend and provide us additional data. So when this data it is collected over time, we can use it to train our agents better. So at that point, yeah, you have all the data that we have in here, we download it, and from here we go and we move it yeah, to the next service that we want to use it. We can put it directly in LLM, we can start putting questions into it, and so on. So this is how it begins. In here, yeah, you can go and you can click it LLM as a judge, and you have different, let's say, evaluators that you're using for this. Okay, so you have the results, how many times it was used, and so on. You have also the evaluator library, and what is also important is that you have the option to use additional LLMs, not just one LLM. You define it into the solution. You can go, let's say, with the GenAI services that we have in here. You can also come with your open AI private key if you have it. You can go with Anthropic and so on. So the solution at the end, yeah, will provide multiple additional evaluations, and based on that, yeah, you can start the advanced development. Now, how these agents are running, yet is also really important. At this point, yeah, all the agents are running in Kubernetes. Yeah? So at that point, yeah, we have different capabilities. Our solution is collecting the Kubernetes logs or Kubernetes metrics, and we are using this solution that is called Log Analytics. And in there, we can, let's say, do different monitorings, like, let's say, from security perspective. Yeah? So we can detect from the data from the entry into application. Yeah? So we have the front end, we have the Streamlit front end, let's say, in my case, and in there, based on the EPM and on the normal telemetry, not the telemetry, I can detect certain types of attacks. From there, yeah, I also have the integration with the logging. And in logs, I can detect, I can create certain security queries, like the ones that you're seeing in here. And based on that security queries, we can go and we can drill down. We can search different types of attacks and so on. So together, yeah, it's not enough to have observability in place, okay? It's not enough. It's not enough to have the metrics. It's not enough to have the events. It's not enough to have the logs and the traces and everything. You need to have something that takes this data and helps you to do the correlations. Initially, we're doing everything simple in a logging solution, yeah, in a log analytics solution. But from here, we added the additional layer, yeah? We added the layer for the, let's say, the AI. So based on that, we can have visibility into the Kubernetes cluster. Okay, so if you go in here, we can go in the cluster. This cluster is the one where we are running all these agents and also the monitoring part, Langfuse. And on this, yeah, you can see, you have the cluster, you have the namespaces, yeah, we can click on it, we can identify the pods that are running, and when you go, we can drill down and see what is collected and so on. The main idea is I'm not a Kubernetes expert, okay? So I'll not go into the Kubernetes. I heard a lot of things about Kubernetes today. I learned a lot of things about Kubernetes today. So again, thank you for making this happen. So how are we with the time?
It's okay. Can go.
15 minutes more?
Mm-hmm.
Oh, okay. That's good.
Yeah.
So we can go with the presentation and we can start taking questions later, or we can take questions now. How do you prefer to do it? Okay, so let's leave the Q&A in the end. So now let me move back to the presentation. And yeah, I showed you how we did it, but how we started, yeah, we forgot to talk about that one. So now, how did it hallucinate, yeah, the LLM? Why it hallucinates? Yeah, so everyone thinks that if an LLM hallucinates, it's something wrong. No, that's correct. This is the way how it was intended. His scope is to provide us answers. If he does not have the data, he is not able to connect to something to get that data, at that point he will hallucinate. Now, when we identify that hallucination, when we observe it. So that's why we have the data, we collect the data, we put it to the applications that we have in the backend, and we try to get an answer. If that is not enough, we get the evaluators that also are gonna have it in there. Next burning problem that we have with LLMs today. Tokens, yeah, everybody's talking about tokens. How much it burned, yeah, how much, let's say, it's gonna cost me today. If we have this, let's say, increasing of the usage, how much is gonna take in time. This month we're gonna leave our tokens, I'm writing code, yeah, let's say, I'm writing code, the LLM is writing the code. But at that point, I want to know when my tokens will finish in that point, in that day. I can bring an additional layer, I'm monitoring those tokens, but I also want to know an additional cost. I have multiple LLMs, I want to know the cost and so on. So that also means that we need to have that layer of visibility. Another thing is that the cache and compute, yeah, for LLMs. When I started this, I did a lot of things. Everything that I was doing in the agent was directly a query against the LLM in the backend. So that means more cost for me, more infrastructure usage, and so on. So when you have things that you already know that you're gonna get an answer, or you have data somewhere, stop using directly the LLM, okay? So I learned it the hard way. Yeah, in December, let's say I started a part of this project. It was an LLM that I wanted to use it for self-learning. So I used my personal key, I got some money into the account, and until the morning, yeah, the agent evolved. But also my credit card bill got at $1,000 lower, and it was not okay. So also this is something that you need to monitor. Don't let an LLM go by himself. So it's also really important to have that part of human in the middle all the time, yeah, for all the things. I don't know when you're gonna have it, let's say, autonomous, and he will be able to do it as it should, but until then, we have multiple questions, yeah, in the platform engineering dilemmas, yeah? So, let's see. Right now, we're trying to fit everything, two worlds, into one world. When you're gonna have something like this, yeah, it's gonna be simple. You have to go again, put a question, you're gonna get the answer without thinking too much. And if you are not sure of something, you have the observability platform in the backend that will show you what you need, okay? So, again, yeah, as a short recap, what you have in here, we have the Kubernetes workloads, yeah, that are the initial world, yeah, the one that we started from here, the cloud native world, yeah, we have that big Kubernetes project on CNCF and so on. Also, how we're doing the deployment, how we're doing the GitOps, how we're doing everything. And also, yeah, at that point, we have the distributed traces for the application that are running in there. Now, we move into evolution, yeah? We add an additional layer near to it, okay? Additional or parallel, depends on the use case and so on. So we have the AI agents, we have the LLM orchestration in the back end. We need to look all the time at the tokens, how they're burned and used and cached and so on. Plus, we need to create something that makes the life of the end user easier, yeah? Maybe an end user does not know what to ask. Okay, so an agent, when you have something like that, is not ChatGPT. Yeah, you go, you put any question, you're gonna receive an answer or something like that. No, agents are created with something in mind, with a scope. So at that point, from time to time, as you've seen into my, let's say, project, you have questions that you have pre-built them. Some of them, yeah, they will questioning directly the backend. Yeah, they're gonna use an MCP server. They're gonna use code execution to run certain queries. So that's it, yeah, at this point, you're not gonna pay additional for tokens. So it's really important, yeah, to know it. Also, what model you're gonna use? We have models that are 10 times more expensive than a normal model. At that point, yeah, we can see the routing, yeah, that is implemented to the application. So when you have that in mind, we know that we're gonna use a cheap one to maybe to write the code, but we need a medium, let's say, LLM that is gonna do some, let's say, routing based on that, and we're gonna have an architect that's gonna use, let's say, the top tier of that LLM category. Okay, so we have agents, yeah, they're going to production, we have SRE, we have platform engineering, yeah, everything like this will always hit a wall from time to time, yeah? Nothing, it's, as we learned yesterday, at 3 something will happen, yeah? It's gonna be in the morning, it's gonna be in the afternoon. So at that point, if we do not have this data, yeah, if we don't know the broken traces, yeah, that happens, if we don't see that error somewhere, that tree will come, let's say, maybe 7 in the morning, 8 in the morning, maybe the auto-healing will not gonna work as properly as it was expected, and so on. My agents are running in Kubernetes, yeah, something's happening in there. So we need to have this visibility. We have, let's say, the FinOps part, yeah? When you're running in multiple cloud, right now, you know, we have multi-cloud, yeah? Everyone is using multi-cloud providers, yeah? We have AWS, we have Azure, we have Google, we have Oracle. So each of these cloud providers has a certain workload. And when you have a tool that is split between 2 or 3, where the issue happened, you're gonna call networking. Okay, look, network is not working. I'm not able to get to my application. No, it's not from me. Okay, you go to the next one. Okay, the operating system is not okay. Someone, restarted the service. No, it's not me. My service is running. And so on. Move to the next one. At that point, we're gonna have 10 different tools. We're gonna have 10 teams and so on. If we gotta get, let's say, the AI collecting all this data, putting all this data together, and also putting questions, yeah, against the data that we have collected and we are using it, then the time we had to resolve issues will go down. So we're gonna be, let's say, more and more in an ideal world where our work will be simplified and we can go and do, let's say, better things, yeah, and innovate more. Okay, so at the end, yeah, the conclusion of this presentation is, at this point, yeah, Open Telemetry is the liant, yeah, is the bridge that with other, let's say, open source tools, yeah, they're helping us, yeah, to evolve. We have a standardized instrumentation that is evolving. We have a centralized collection, distribution collection, yeah, tracing and all of that. And we can also have a single pane of glass, which is the Grafana. And at this point, let me go and show you multiple dashboards, yeah, that were created in the backend, yeah. So you've seen it, we have all the other applications, we have multiple let's say, metrics that are collected, and based on that, we can drill down, yeah, and we can, let's see, find the solution that is helping us. Okay, so at this point, yeah, we have traces. We go on a trace. We can also drill down on that trace, and we can see it. Okay? So, let me go back to the presentation. Yeah, this is what I already told you. Yeah, so we have a lot of evolutions and things like that. So let me move to the next one. Already presented the line graph application. Yeah, that we have it. We've seen the collection, how it's done, and we put it in there. And at the end, we have the multiple visualization tools that are in here. This is a little bit about the Open Telemetry, yeah, that we also presented. And in here is the part of the OCI coordinator. So this is the agent that you've seen it. Yeah, so we started with a simple agent that initially was used for Teams messages from Slack. We have the input, we have the classification, we have the router. After that, yeah, line graph is the coordinator. We have all this data, and we're sending the data to a telemetry, yeah, observability layer that is collecting all this data and is splitting across multiple services. So based on this, yeah, we did multiple tests and we got to the conclusion, yeah, so this is, let's say, the one that fits our customers, yeah, at that point. But on the next one, yeah, who knows? Maybe we're gonna go with something new because everything is evolving and we know exactly how it's doing. So we've seen it, we've seen the demo, we have the user prompt, we've seen how the LLM goes from one part to another. We have the agent that selects different things. We have the tool execution part that is, let's say, selecting different capabilities in the backend of the agent. And at the end, yeah, we also have the capability to monitor the hallucination. Okay, so let me move this forward. Okay. So, yeah, okay is the runtime. We're here because of Kubernetes, yeah? So Kubernetes was the one who started all this discussion because we run everything in Kubernetes right now. But from there, yeah, from the runtime, we move to the Open Telemetry, yeah, who help us to bring this visibility layer. We go to, let's say, to our, let's say, native monitoring solutions. And at the end, yeah, the goal was to have the full Gen AI monitoring and all the views in there. So I will move at the end. Maria?
Okay, thank you, Adrian. Basically, I hope we gave you an idea of how Open Telemetry works in this AI world. And to sum up, today more and more organizations will adopt a multi-cloud AI strategy. And it's very important to actually understand that the traditional observability is not enough. You need to see what is happening behind an AI request, and I don't know why the AI agent hallucinated, which one prompt caused a specific issue, or token costs, as we said. So by combining Open Telemetry with other open source observability services, you can build actually a centralized vendor neutral platform for AI workloads across different cloud providers. And perhaps the most important message is that adopting open standards today will give you flexibility tomorrow. Models will change, frameworks will evolve, but standardized telemetry will continue to work across distributed AI environments. We are at the end of the presentation. If you scan the QR code on this PPT, you will find useful resources about what we've talked today, and also our LinkedIn pages in case you have additional questions that we can cover in the Q&A session now. So thank you everyone for joining our presentation today, and I hope you found useful information. In case any questions, please address them now. Thank you again.
Thank you.